Okay, so question for you guys on your preference. Um, we've finished up all the content that I want to do. I know that the people leaving on Kairos, there's a handful of us that are going to be gone for a couple of days. So Tuesday and Thursday this week, I'm going to do some just some AP review and then some generic test review. Thank you. Finn, this is for you. Which would you guys rather do today? The specific test review or the AP review? What would you rather do today? The test review stuff? Okay. We'll plan on that then. So Thursday, those of you that are gone for Kairos, we're just gonna do part of an AP exam and talk about, go through it and talk about the results afterwards and take questions and stuff like that. That'll be the class. So you guys can do that or not when you get back or after you've settled it in. I'll give you what we did. Doesn't matter. There's no grade attached to it. It's just for you for practice. Okie doke. The test format for this last test 7 we had talked about already, but we'll do it again as I've kind of finished writing everything. So part 1 is no calculator. It's going to be something we're going to do in class. So the things you should be able to do are, verify a solution to a differential equation, find equilibrium values for a differential equation, find the general solution to a differential equation using separation of variables, find the specific solution to a differential equation using separation of variables, given a boundary condition. So f of 5 is equal to 10 or something, so you can solve for c. Find the specific solution to a linear differential equation using an integration factor, given a boundary condition. Match differential equations to their slope field. And then I'll have one differential equation based FRQ for you guys to do. Part 2 is open calculator, take home with a group of 3. So again, there are 21 of you guys in here. So 7 groups of 3. So I wrote 7 versions of this for you guys to work on with your group. It's just going to be asking you to compute the integral. So the methods that might come into play: integration by parts, completing the square, partial fractions, polynomial division, U substitution, trig substitution, improper integrals, etc. So I think there's 5 or 6 integrals, but that's part 2. It's just 5 or 6 integrals. I can't remember how many exactly. You'll use some or all of these methods at points to complete them. We'll give you guys, probably give that part to you guys Wednesday of next week and ask for it back the following Tuesday or something. So we'll give you a day in class that you guys can meet with your group and kind of talk through things and start on it. Let you keep it through the weekend, bring it back the next class after the weekend. Seem fair? Seems like enough time, right? But that's the test format. Does that, you guys feel okay as to what's covered and what's not, Paulo?
What form will you do part 1?
There's no multiple choice on this one. The closest I have is matching differential equations to their slope field, so that's like a matching based question. So I'll have, I don't remember, it's 4 or 5 slope fields and 4 or 5 differential equations, and you pair them up. So there's like a test bank, or like it's more like a matching style question, but I think it accomplishes the same thing. So I didn't have any multiple choice in this one. So they're mostly just, aside from the one matching set, everything else is just like a normal math test question. Does that feel okay? Yeah.
For the part one, when we're doing like differential equations stuff, should we know how to do the integration by parts?
I don't have anything in there where you need to use that particular technique for part one. So I think that did come up a couple of times in like the 9-5 homework, where you might have needed to rely on integration by parts to do some of those, or once or twice anyways. But I did not, when I built these questions, I did not build any questions so that you needed to use that particular technique because it was being tested later. So, other format questions or anything? Okay. So the first thing that I wanted to do as far as review stuff, I was going to focus on part one pieces, since it's the part you'd actually probably be studying for. The part two part is probably stuff that you just need to make sure you know how to do going in, so it's not like a 10-hour process to try to relearn how to do these things. But and we can do some part two stuff, but I want to start with the part one stuff, and specifically looking at the some of the homework quiz stuff that had been completed. This seems like a weak point for us, like matching an equation to a slope field, or picking out an equation from a slope field or whatever. So I went and stole like all of the available slope field multiple choice questions from the test bank on the MyAP and just dumped them into here. So my plan would be to just kind of go through some of these and talk through these and help see if we can get a little bit better at doing this. So I want you guys to be active participants here. So like if we're doing something you're not sure of why we're doing it or what I just did or how I know, like please speak up so we can kind of get things straightened out here a little bit, because it seemed kind of hit or miss, and that's fine. Like this can be tricky if you're not sure what to look at or how best to approach some of these things. All right. So the slope field for a certain differential equation is shown above. Which of the following could be a specific solution to the differential equation? Now, what is your instinct as to how to approach this? This is what I would do. If I trace the function in that's kind of defined by the slope field here, I'll get a shape for a graph, and then I'm just going to try to match that graph to the functions I see below. So I'm going to rely on what I know from like Algebra 2 and pre-calculus about the shape of these graphs. So like I know that, y equals x squared would look like this. That doesn't fit at all, right? E to the x would look like this. That doesn't fit, right? Because this should be doing something like that, right? Everybody agree? Okay, so that's out. E to the negative x just looks like that. Again, the wrong kind of concavity on those slopes, right? You guys okay with the route that I'm going on this? Cosine, I know, kind of looks like this. And that's not quite right because it should be like horizontal up top. Even though we're getting this right kind of concavity, that doesn't seem right either. Do you guys agree? You see what I'm saying? And then the graph for the natural log looks like this. And bingo, that definitely looks like what's going on there, right? So we feel okay as to the approach that I would recommend taking there. That seems the simplest to me. It's just like, what do these graphs look like? Which one of those resembles the slope field I'm looking at? The slope field for a certain differential equation is shown above. Which of the following could be a solution to the differential equation with the initial condition y of 0 is equal to 1? Now, probably worth checking, if I plug 0 in for x, do I get 1 for each of these? Because if they don't, I could throw it out immediately. Unfortunately, all of them I do get 1. Everybody can check that real quick, I hope, in your heads. So what I would do, here's my 0.01. So if I draw this, that looks like the graph, what my graph should look like, right? Everybody agree that that's approximately tracing the slope field? Which ones can I eliminate right away that are just totally wrong? Well, definitely can't be quadratic, right? Like, no way that's quadratic. No way it's exponential. Does it look like half a circle? Right, that's what that would be. No way. So I'm left with 2. Could it be cosine? Wrong kind of concavity on it, right? So we're left with this guy, which should make sense because if I think about this, this has a horizontal asymptote at like y equals 0. Certainly looks like we're kind of going down to that. So I like that a lot. That makes sense to me. Everybody feel okay there? Okay. All right, the next one says, shown above is a slope field for the differential equation dy dx equals y squared times 4 minus y squared. If g of x is the solution to the differential equation with the initial condition g of -2 is equal to -1, then the limit as g goes to infinity is what? Well, I'm going to start by plotting g of -2 is equal to -1. So that's like the point -2 comma -1. So it's probably here. You guys agree with that? Something about there? So if I graph this, it looks like it would be stuck in between those two asymptotes, right? Do you guys kind of see that? So the limit as x goes to infinity then is going to be this end, we'd say that limit is 0. Is this so far feeling okay? All right. Shown above is the slope field for which of the following differential equations? This is probably this is what the multiple choice on the homework quiz resembled, right? And this is probably the more difficult version. This is what the matching is going to be. You'll get the differential equation and you have to match it to the slope field. So what I would do first is I would identify the stationary points, or nope, that's not what they're called. What are we to call these things again? Equilibrium values, that's what they're called. So I'm going to identify the equilibrium values for each of these. So basically, I'm just going to factor these things and set them equal to 0. And I'm just, at some point, I'm going to be stop showing the algebra. Is everybody okay with me just looking at the equation and writing them down? Okay. So this guy looks like it's going to be the biggest problem in sorting the two apart, correct? Because they have the same equilibrium values. Let's go look at the graph now. So I have an equilibrium value here that appears to be y equals 1, because the slope is 0 there, right? Because it's a horizontal. And I have equilibrium value here at x equals 0. Do I have any other equilibrium values? I do not, right? So we can go and eliminate those spots, correct? We're just stuck now between these two. So what I am going to notice here is that really the only difference between these two differential equations is one is an x and one is an x squared. So if for this one, if x is negative but y is greater than 1, the slope then should be negative. Everybody agree with that? You guys agree? You see what I'm doing? Here, again, if I pick x as a negative value and a y greater than 1, my slope should be positive, right? Because the x squared. So that's what I'm going to do to tell the difference, is I'm going to find a point on my slope field that has an x value that's less than 0 and a y value that's greater than 1, and look to see if the slope is positive or negative. That will allow me to tell the difference between the two. So let's say that point there, that has a negative x and a y that's greater than 1. Everybody agree? The slope there is negative because that piece of the slope field is angling downward, right? So that's what I need to tell. My answer should be A. that feel okay with you guys? Yeah.
So for the equilibrium values, is it just setting it equal to 0?
Yep. That's all I'm doing is setting that differential equation equal to 0 and solving to see if there's any values for x or y that permanently will always make the derivative 0. For c, there is no constant, right? When y is 1 and x is 1, the slope is 0. When y is 0 and x is 0, the slope is 0. But it's not like this one value of x or this one value of y will always make it 0. Nate? Sure. Does this feel like it's helping, guys? Kind of walking through some more of these? Again, they're not like tremendously difficult, but if you don't know what you're looking at, and this one apparently glitched because oh no, this is the slope field. Okay. All right. So once again, what I'm going to do is I'm going to start by looking at I'm going to do like the reverse process here. So I'm going to start on the slope field, look for equilibrium values, and then go down and see which one of these hold for my other one. Okay with that? So y equals 4 is an equilibrium value. Y equals 0 is an equilibrium value. Do we see any vertical ones, though? No, right? So I can immediately eliminate A and C as possibilities. You guys agree with that? Because those have equilibrium values at x equals 0, and I do not see that in my slope field. So far, so good. Okay. So the last question here is, let's say when y is less than 0, this slope should be positive because I'll have negative times positive, right? Everybody agree with that? When y is less than 0, here I should have positive times positive, so that should be positive. So I'm just going to go and look at the part of my slope field where y is less than 0 and look to see if that is positive or negative there. Since those slopes are all angling up, I know those are positive slopes, so I want answer D. Does that feel okay to you guys?
Is B supposed to be the same, or is it supposed to be?
Oh, I wrote that the wrong way, didn't I? That should be negative. Excuse me. Thank you. I was wondering, so we had some confused looks going. I'm like, what is going on here? I'm going to pause for a moment. How are you guys feeling? Do we want to keep doing this, or do you think you kind of got the idea? There's like 25 of these questions in here, so like we can go for a long time if you want. That's fine. If this is productive and helpful and you're like, yes, please, this is helping a lot, we can keep going. I don't have an agenda for today that I need to do. So like, if you're like, yes, let's keep going, this is productive, I feel like I'm catching on here, but it's still, that's fine. We'll keep going. Is that what we want to do? Okay. I saw one person shake their head yes, so I'm going to keep going because everyone else just stared at me like I had a third head growing out of my head. Which is a weird thing to say because I would imply I had two heads normally, which is still a weird thing to have going. Anyways. All right. So here it says, which of the following is a slope field for the differential equation x squared plus y squared? So notice here, there's no equilibrium values, right? But what I also notice is that x squared plus y squared is always positive. So I'm going to go down and look at my perspective slope fields and eliminate any one where I see a negative slope anywhere. So like this one, that's got a negative slope in it. You're gone. This one, those all look positive to me, right? That one's a possibility. This one, though, oh boy. Negative slope, you're gone. This one, those all look positive there also, right? Okay. Now, the question becomes, how do I tell the difference between, how do I choose between D and B? Well, here I notice that I have an equilibrium value at x equals 0. Well, that's not right. You're gone. B has to be my answer. Alex?
So, for the graphs, there's only
There's like 4 or 5, and it's a matching situation where there's like, I think there's 5. Like 5 slope fields and 5 differential equations, and you just match them, the equation to the graph. Does this feel okay as to how I'm picking up these through? And ideally, you can do this really quickly, right? There's not a lot of computation to do. You have to be careful and think about it the right way, but there's not like a long process I have to do. There's nothing to compute. I'm just kind of like looking at what can I know about, you know, this differential equation or this slope field, and just like, oh, can't be this one because it contradicts this thing that I know has to be true. And more or less, I'm just trying to process of eliminate this. I'm not trying to construct slope fields for each differential equation. That would be a nightmare, right? No, thank you. So we have another one. Which of the following is a slope field for this differential equation? So I know I have an equilibrium value at x equals 0. Everybody agree with that? And what's going to happen when y is equal to 0? So there, the slope field should go vertical at y equals 0. Everybody agree with that? So that's the first thing I'm going to look for, is I'm going to eliminate anything where I don't have horizontal slopes at x equals 0. So x equals 0 would be this line here. Do you see vertical or horizontal slopes there? I don't. You're gone. I look at this one. Do I see horizontal slopes there? Nope. You're gone. Here I see horizontal slopes. Well, that's a possibility. And here I see horizontal slopes, so that's a possibility. So it's going to be, oh, and I have one more. And here I see horizontal slopes. So that's a possibility. So it's going to be one of these last 3. Now let's look at the y parts, right? So the graph, or my analysis, also showed that when y is equal to 0, I should get vertical slope lines on my slope field. Oh boy, what did I do? So let's go look at our possibilities here. Y equals 0. Is that, does it look like I have vertical at that spot? I agree. You're gone. But if I look here, it definitely looks vertical out here, right? But if I get to the middle, not so much, right? So this one I don't think is right, but I'm not completely convinced. Let's look at the next one. Again, we're looking at y equals, oops. Oh, come on. Looking at y equals 0. And again, I look pretty good way out here. But in the middle, I mean, it's hard to tell what's going on. So it's going to be choosing between D and E. You guys agree? So if it's not completely clear, I'm going to keep on going with my analysis. So I'm going to think to myself, okay, if this is just x over y, in quadrant 1, all my slopes should be positive because x and y are both positive. In quadrant 2, all my slopes should be negative because y is positive but x is negative. In quadrant 3, all my slopes should be positive because it's going to be negative over negative. And in quadrant 4, all my slopes should be negative. Everybody agree with that? So that's the next thing I'll go and check. Okay, so looking at this one, here, all my slopes appear to be negative. All my slopes here appear to be positive. Here they look negative. Here they look positive. That ain't it. In fact, that's probably negative x over y is probably what that is. If I look over here, all these slopes appear to be positive. All of those negative, positive, negative. That certainly seems like my answer. Feel okay as to what I looked for there? So again, I'm usually starting with the equilibrium values. I'm going to use that to eliminate everything that I can. And then I'm going to go back to what's left and look for how can I tell the difference between these things? And pick maybe a specific value or specific x and y and try to look what's going on. Or specific region and look what's going on. All right, why don't you guys take a minute? Let's try to do this one in our head. I'll give you guys a minute or so to kind of think on it. Because you've seen me now do, I think 7 of these things, should be getting an idea of how to do this. Let's let you guys try some. And we'll talk through it afterwards. All right, looking from this slope field, what equilibrium values do you see? Y equals 0. And then x equals -1. Using that, which answers can we eliminate immediately? Which ones? A, B, and E. Excellent. Everybody agree with that? Now, if we think about this, this is like y times x plus 1. And this one is x times y plus 1. So notice that D isn't going to work either. So our answer has to be C. Right, this one is just the wrong, they're flip-flopped or whatever. How did that one go? Felt okay? So this is a new kind of problem. We haven't seen one like this before. It says a portion of the slope field for the differential equation x minus y is shown in the figure. If the linear function y equals f of x is a solution to the differential equation such that f of negative 1 is equal to negative 2, then f of 3 is equal to what? Well, let's start by plotting that, negative 1, negative 2. Is right there. Everybody agree with that? So if I were to draw that solution then, looks like that, right? F of 3 appears to be 2. Everybody feel okay with that? That's exactly what I would do to proceed. I would just sketch in the solution and then trace it over and see what the value for x is. Even if it was like in a weird spot, it's still the same thing I'm going to try to do, is just kind of like sketch in the solution and trace it over. I'm not doing any computation on something like this. I'm just kind of like using my eyes and understanding what it is that I'm looking at to sketch in a solution, use that to make an approximation. All right. Which of the following is a slope field for the differential equation? 1 minus x squared. So what can we say about 1 minus x squared? What are we going to be looking for in the slope field? Okay, is there any? Right? So we do have equilibrium values. What else could we look for? Actually, let's see if that's enough, right? Let's just go and see if that's enough. How's A look? Looks like it meets our equilibrium value criteria, right? Can't eliminate that. What about B? Does B work? No. How about C? I don't know, it's hard to tell, maybe, right? How about D? No. Okay, so we're going to be picking between A and C, right? Now, I don't need any more than just looking at it right now to tell. What do you notice that C has that it shouldn't? Has another equilibrium value at x equals 0, right? That shouldn't be there. Got to be A. Everybody feel okay? This one all fits on the screen at one time. Why don't we try this one? Give you guys a minute to look at it and try to figure out which one it is. I see Maria squinting, so I'm going to try to make it a little bigger. She had to sit up and start squinting, so I'm like, oh. All right. Who can tell me the letters we can eliminate right from jump? Well, I'd say it's C and D. Right? Which one? Why C and D? Because this is y equals -1 here, giving us an equilibrium value, and those do not have -1 as a 0. Everybody feel good there? Okay. How are we going to tell the difference between A and B now? Well, let's pick a region from the graph where the slope is all either positive or negative. So maybe I just pick this one, right? There, the slope is positive. Everybody agree? The x value is negative, and the y value is less than -1. Everybody agree with that? So if I do that here, I'm going to get negative over negative, which should be a positive, right? Which matches what we see. If I do it here, I'm going to have negative of a negative over a negative, which should be negative. That's not what we want. I want A. Is everybody kind of seeing what I'm doing there? So you could pick a specific xy if you wanted to, and like try to estimate the specific slope. Usually just the sign is enough though. Right? You could pick like, oh, I'm going to pick -2, -2. You know, and look at the two slopes and see which one approximates, you know, that size. That's fine. You could do it that way too. And there's nothing special about the region I picked other than all the slopes are positive or negative in the region that I picked. But usually that's an easy way to do it. This one will fit all on the screen for you guys. Let's do this one. Why don't you guys try this one? Give you guys a minute to think about it. Should be able to do this just from the equilibrium values, right? What's our answer? B. Because this is y equals -2, and this is y equals +2. I heard a couple of D's, right? Yep, easy mistake to make. So I would really encourage you guys, like, write in the equilibrium value next to it, because it's easy to goof up what's x and what's y. But that's good. All right. Let's do this one, and then we're going to move on to do something else. Sound good? I think we probably had enough practice at this for today. How in God's name am I supposed to solve this thing? The slope field shown is for the differential equation, yada, 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 where k is a constant. What is the value of k? What do you think we're going to need to use from the picture? What piece of information? The equilibrium value. What is that equilibrium value? Y equals 4. That's going to make the derivative then equal to 0. There we're at go. Everybody feel okay there? So k is going to equal 8. Feel good? Okay. I'll dump the answers into this also. There's still like 10 or 11 here that we haven't done yet. If you want to practice some more on this stuff. But I think this is a good substitute for, like, if you got to match slope field to equation, right? It's basically the same problem. It's just multiple choice instead of matching. Close enough proxy of practice, right? All right. So we did a whole bunch of stuff there. What else do you guys want to work on? Do you have questions from homework you'd rather look at? Doesn't matter to me, guys. Like, this is the topic that I've looked at what you've done that I'm like, well, we need to spend a little bit of time doing some more practice on this. Elena. Yeah, I mean, this is an old thing, but we can certainly do some of this. What did you want to look at? Number 3? Absolutely. Okay, so it says confirm that y equals log of yada 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 is a solution to the first order differential equation. Y prime times 10 to the y is equal to 15x squared over the natural log of 10. So what I'm going to do is I'm going to start by calculating y prime. Everybody's okay with that? What is the derivative of log of 5x cubed plus 2? To do that, we need to do a chain rule. So the derivative of the outside is 1 over the insides times, since it's not natural log, we have an extra factor in here. One over the natural log of the base. Because this is log base 10, right? Everybody's okay there? And then we have times the derivative of the inside. What's the derivative of 5x cubed plus 2? 15x squared. Eliana, so far so good? Yeah. Okay. So we have that. Now we're going to do y prime times 10 to the y. Everybody's good so far? And now I need to just show that this is going to simplify down to give me that.
There's that.
So what do you notice right away that we can do? It says show that this is, so I'm just now plugging the derivative into the equation and just showing that the left-hand side is going to give me the right-hand side. So we can do that, right? Exponent base 10 cancels log base 10. And then what's going to happen, use a different color, then those guys would cancel, right? And what are we going to be left with? Exactly what we needed. Oh, that's because I copied it down wrong. It wasn't x squared there. We just copied it wrong. Sorry, guys. Thank you. Hammer me on those details. I need it. Elena. Yeah? Okay. So again, it's just like find the derivative, plug it back in, simplify to get the other side. That's usually the easiest because differentiation is typically going to be easier than like trying to solve that differential equation for y and show that you get that y. The integration's hard. Particularly for something like that looks like a nightmare to me. But this is an example of, that first type of question, right? Verify the solution to a differential equation. That's what we're talking about doing. Is something like that. So here's solving a differential equation with a boundary condition. Let's do this one. 6 So the way I would start is instead of y prime, I'm going to think about this as dy dx. And now what I want to do is I want to get the x's and y's on different sides of my equation, right? I want to separate the variables. So I'll divide both sides by tangent y. And then multiply both sides by dx. So far, so good. And then we'd want to integrate both sides now, right? Can I integrate? Do you guys know how to do 1 over tangent? We don't have an antiderivative rule for the way that's currently written, right? I can't u sub it. What should I do to that? This is what I would do. So I would think about that as 1 over tangent as cotangent. Cotangent is cosine y over sine y. And then if I do a u sub, so what I'd really be integrating is like 1 over u du. Do you guys see that? It's okay? So this is going to be the natural log of the absolute value sine y equals, now how am I going to integrate the other side? X plus 1 over x. Can I integrate it the way it's currently written? You should answer no to that. What should I do? Well, I'm just going to rewrite it as 2 fractions with a common denominator, right? And that is super integrable now for me. And then one of these guys needs a plus c. I'll put it there, I suppose. I make a mistake here. Okay. So now we just need to use that boundary condition, right? But I don't think I did that right on the review. What did I do? What did I get from there? So I did that. Great, great. Sine of pi over 2 is 1, apparently. That's... That's not right. Good job, Mr. Kulik. All right, so what we would do, we just plug some stuff in now. Natural log, sine of pi over 2 equals 1 plus natural log 1 plus c. And the natural log of 1 we know is just 0. So c should be the natural log absolute value sine of pi over 2 minus 1. And that'll be good enough, I think, right? This is not one where I try to get y by itself, and in fact, I tell you don't do that on this one because it looks like a nightmare to me. What about you guys? Yuckarooskies, right? So that's an example of that, and I guess if you stopped when you just had the plus c, that's, you know, solving for separation of variables. Oops. Let's do this one. What should I do first? Separate variables, right? So I want to get the y's and dy's on one side and the x's and dx's on the other. So there we did it. Everybody agree on the separation? Integrate both sides. The antiderivative of y dy is real easy. But how do I do the integral of the natural log of x over x dx? What I notice is that if I think about this as the natural log of x times 1 over x dx, instead of thinking it as the natural log of x of over x, that helps me see what to do. I would do a u sub here, where the u is the natural log of x, because du then is 1 over x dx, which is exactly what I have. So the integral of that is just going to be u squared over 2 plus c or if I multiply both sides through by 2. Now I could write this as 2c, but like 2 times a constant, still just a constant, right? So I'm going to drop it out of there, and then we'll just square root both sides. So far, so good? All right. So it says consider the differential equation t times the natural log of t dr dt plus r equals t e to the t. Yuck. It says write this function in the standard linear form. P of x times y equals q of x. So the first thing I want to do is get that y prime by itself. I am so flippin' sick of you. So I'll divide both sides by t e to the t, right? I'm sorry, t natural log t. That's supposed to be plus. Everybody okay there? Everybody feel okay with what I've done there to rearrange it to get into linear form? Now bless you, how do I find that integrating factor now? Yeah, so we say I of x equals e to the integral of p of x dx. How am I going to do the integral of 1 over t times natural log t dt? Again, I would think about this as 1 over t times 1 over the natural log of t. The u that I'd pick is the natural log of t, because du is 1 over t dt, right? So I'm going to have 1 over u du. So far, so good? So that's going to be the natural log of u, which is just the natural log of the natural log of t. And those guys will cancel each other out. So I'm left with natural log t as my integrating factor. So once I've found my integrating factor, I'm going to multiply that by both sides of my equation. notice over here that that's going to cancel out and just leave me with e to the t. What does the right-hand side give me, though? Who remembers? That's just going to turn into the integrating factor times like the y variable, or the derivative of, I should say. So when I integrate both sides, the integral cancels the derivative. And then I can just divide both sides by the natural log of t. And there we go. So we've done this. We did that. We did that. So the only thing we didn't do was like an FRQ style differential equation, but it's going to be doing the same, like separation of variables, or like boundary conditions, or like plug something into this derivative and talk about, or what its graph, the graph of the solution might look like, or something like that. Conceptually, it's still using all the same ideas we've talked about to this point. You guys all look exhausted and beat. Are we okay? No. Well, the good news is that there's nothing intense next class. You know, Monday next week will be the part 1. So you have like 6 days to kind of get your house in order, right? And hopefully you feel pretty good about the matching piece. The differential equation piece. We spent a bunch of time there doing extra practice. That's not hard if you know what to look for, right? And I'll put in the answers to those extra practices. That's the slope field practice there under chapter 9 is what we worked on today. I'll put the answers in. And another part of this test is take home. That should feel relatively good with partners or with groups. You know, that's not bad. If you figured out your groups of 3, everybody's required a group of 3. Okay, there's exactly 21 of you. I wrote exactly 7 tests. There's no solos. There's no 2-person group. There's no 4-person group. Specifically groups of 3. Start figuring that out in advance, like who you're going to be working with. We'll give you guys those on Wednesday next week. Give you the entire period to meet with your group and start working on stuff. You know, if you want to take pictures so that the other people can work on, you know, like I only have 1 copy of the thing. I guess I could run extra copies, but I prefer not. And then, you know, like that'll be Wednesday. Friday we'll do some more AP practice. You have the whole weekend again to kind of continue working on the take-home piece. And then it'll be due on Tuesday the next week. So if you run into problems on Monday, you can still come track me down and ask questions or whatever. As you're putting your finishing touches on. Alex?
Will you give us the take-home?
We'll give it to you on Wednesday.
Or next week?
After we've done part 1. I don't want you to worry about the take-home while you're trying to study for part 1. But it's like that gives you like 6 days or whatever for the take home. Does that feel pretty reasonable? It's like 6 questions or something, or 5 questions, something. It's not like it's a huge long thing, although, like, I'll be honest, the integrals are not simple. Like, it's hard still, but not using any techniques we haven't seen. So that's the next week or two, right? So we just have the last test and and some AP practice. I wanted to say I also put in so all the rest of the homework quizzes I looked at and just put zeros in if you haven't attempted. Don't worry if you haven't, but as you're finishing these things, make sure you remind me every week or so, or every couple of days. I'll probably go back and take another pass through and start entering in the new ones that have been done. But the last chapter 9 and chapter 7 homework quizzes are up on my AP. Some people have attempted everything already. But aside from the chapter 7 problem set for Sunday and the final test number 7, those are the last grades to go in the grade book for this class. So there will be nothing, like, once you're done, we can, if you want to do a retake or a double, we can sort that stuff out. And your grade will be kind of where your grade is. Sound good? Losing my voice.